So the first part of chapter 8 that we talked about was to figure out if something is quadratic. Remember that when we are figuring out if a function is quadratic and it's written as an equation, what are we looking to see? We are looking to see if it is in the format of y equals ax squared plus bx plus c. We know that if the highest exponent is a power of 2, it makes a u. So looking at this, I can minus 7x squared from both sides, and I would get y equals negative 7x squared minus 2. And so yes, this is quadratic because the highest exponent is 2.
Can a be negative then?
A can be negative because remember that a means it opens down if it's negative. So in this case, the highest exponent is 2. Power of 2 makes a u. So yes, this is a quadratic function. That when we have a table, we have to remember that in order to check to see if something is quadratic, what am I looking for? I am looking to see that the change of the change of x is constant, and that the change of y is a double difference or a double sum. We're looking for the double difference to be the same. So if I look at change of x, from negative 2 to negative 1, I go up by 1. Negative 1 to 0, up by 1. 0 to 1, up by 1. 1 to 2, up by 1. So far, so good. The difference for negative 8 to negative 1 means I went up by 7. From negative 1 to 0, I went up by 1. 0 to 1, I went up by 1. And 1 to 8, I went up by 7. I'm looking at the double difference of y. From 7 to 1, I went down 6. From 1 to 1, I went up 0. I'm already not a double difference. So, no, because the second difference in your y's is not the same. So if I had this table of values, if I was asked to see if it was a quadratic, I would once more look at the change of x. So I went up by 1, up by 1, up by 1, up by 1. So far, so good. My change of y, I went up by 3, up by 5, up by 7, up by 9. And then I look at the double difference, and it would be plus 2, and so on. So I know that because of the double difference in y's and the constant change of x, it is quadratic. Number 3 is asking you to tell whether the graph opens up or down. What part of the quadratic function tells me that I open up or down? The A, right? In this case, if I look at my y equals ax squared plus bx plus c, I know that A is positive 1. So therefore, I open upward. Because A is positive. Yes, A is greater than 0, or A is positive. The next question asks me to find the axis of symmetry. The axis of symmetry given a function as an equation has to use the formula what?
X equals opposite b divided by 2.
Nice. X equals opposite b over 2a. Here, if we look up here, so a is -2, b is 4, c is -3. I only need a and b, so x equals opposite of b, which is 4, over 2 times a, which is -2. This is going to give me -4 over -4, which is equal to +1. But the axis of symmetry must always be an equation. So you cannot just say 1. You have to say x equals 1. Because this is telling me that I am a vertical line, right? That is an x equal to equation. So the axis of symmetry for this question is that x is equal to 1. Please remember, when you see words in math, the only reason that we get intimidated by them is because they are words and we want to process numbers when you are in math. So here, we know that the unit we're covering this section is a parabola unit. We know that we're going to be talking about graphs that look either like that or like this. In this example, it is talking to me about the height of a soccer ball that is kicked from the ground, and it gives me the formula. It doesn't even ask me to come up with the formula. It says the height of a soccer ball that is kicked from the ground can be approximated by the function blah blah blah, where y is the height in feet and x is the number of seconds. So if I kick the soccer ball, it's going to do this. They're telling me y is the height. So the distance is going to be y, basically. That's how high it is. And the number of seconds is how long it takes for it to happen. So even if we didn't draw a picture and we just looked at the algebra behind the scenes, we would see that the question that they're asking me to answer is the time. So x, what is x? For it to reach its maximum height. If I was to look at a parabola that was like this, the maximum height is going to be located at this point right here, which is called what point of the parabola? The vertex. Very good. The maximum height is the maximum or the vertex. I am looking for the x value of the vertex. Not the x value, the y value, because height is y. Y is height. I am looking for the y of the vertex, because that is what height is, the y value. So in order for me to get the y value and the time, which is the x value, okay, in order for me to get the y value, which is the maximum height, I have to first figure out what the vertex is. And in order to do that, I am going to do the axis of symmetry first, because once I get the axis of symmetry, I can plug that in to get the y value of the vertex. The maximum height is the y value of the vertex. In order to get the y value of the vertex, I have to get the x value. And the x value is the axis of symmetry's value. So I'm going to say negative b over 2a, where b is 16, and a is negative 16. And when I do this, I get the opposite of b, which is negative 16, over negative 32. This is going to give me 1/2. What this is telling me is that my x value of the vertex of the maximum, my x value of the maximum is 1/2. So in order to get the y, okay, I'm going to plug that x value into the equation, 16, negative 16x squared plus 16 times x. I'm going to plug in 1/2 here, because remember that the 1/2 is the x value of the vertex, and they're asking me for the maximum height, which is y value of the vertex. So I use my math and my calculator. 1/2 squared is 1/4. 1/4 times negative 16 is actually negative 4, plus half of 16 is 8. Negative 4 plus 8 is 4. That means that my y value of the vertex is 4. This means that the maximum height is the y value of the vertex, which is 4 feet. That means that the height that I am going to get when I kick the ball is 4 feet. That's the highest it's going to get. That's the highest it's going to get, because the maximum height, going back to our picture, if I kick a ball, the maximum height is going to be the vertex, but a vertex is x comma y. X is telling me in the problem is the number of seconds. They want to know what is the height, which is y, the value of y. This is the reason to why I need to use x equals negative b over 2a to find the x value of the vertex. Then I have to plug that x value of the vertex back into my equation to get the y value. And the y value, which is 4, is telling me that I am going to reach the maximum height of 4 feet off the ground. That's half of the question. They want to know, the second half of the question is, how many seconds is it going to take for me to reach the ground again? They want to know, what is the time it takes to reach the ground again? So the second part of the question is asking me exactly what you just said. What is the value of t when my height off the ground is 0? Y is the height of the ground. So instead of my equation being this, they're asking me to substitute 0 in and solve for x. Because if the equation is y equals negative 16x squared plus 16x, and y is telling me how high off the ground, and x is telling me how many seconds, and the second part of the question is how much time. If I have it already set equal to 0, then I know that I can solve by factoring or square root method or x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a, right? Quadratic formula. In this case, it is probably easier to GCF it. I am going to factor out negative 16x, and I'm left with x minus 1 equals 0, correct? I factored out negative 16x from both of these terms. That left me with x minus 1. Then I remember that in order to solve, I have to set each part equal to 0. So I'm going to set this equal to 0 and solve. Divide by negative 16. Doesn't change at the fact that x is 0. This x is 0 is telling me that before you kicked it, 0 seconds before you kicked it, you're on the ground. Yeah, I know that that's my first time that I'm on the ground is before I kick it. The next time that I'm on the ground is when x minus 1 is 0. X equals 1. That means that 1 second after you kick the ball, you are going to be back on the ground. So I am on the ground at 0 seconds, and then after 1 second passed, I am back on the ground. And it makes sense that when I was solving my equation the first time around, if you remember that x was equal to, I believe, 1/4 or 1/2, that means half of a second after you kicked it, you reached your highest height.
Don't you just double it?
And then when you were at the bottom, yeah, you're down after 1 second. The other way, which if I know that in half a second I was halfway done, because remember what that means. The parabola goes like this. In half a second, you were up here. That means that in another half of a second, you're going to reach the ground again. So after 1 second, you're already back on the ground. So part 2 is it takes 1 second to be back on the ground after you kicked it. And there's 2 ways of doing it. Way number 1 is the way that we did it where we just literally set it equal to 0 and solve for x. And way number 2 is to use your rational thinking. If we used x equals negative b over 2a in order to find out the x value of my vertex, and x represents number of seconds, then what this 1/2 is telling me is that after half of a second, you are at your maximum height, 4 feet off the ground. That means that after another half of a second, you're going to be back down to 0, which means that if this is half a second, the other half is 1 second altogether. So the way that your final answer would be stated would be your maximum height is 4 feet. Okay, that's the first part. And the time it takes is 1 second. Number 6 is asking you to find the vertex. Just like we just worked on a real problem in a real world application, we know that the vertex is the, in this case, maximum. Now, looking here, this is the part that I want to just make sure that you guys understand. Sometimes you have to use the algebra, and sometimes you just have to use your logical, rational thinking. It is okay to be rational and logical, and not always have to use a math formula. Looking at this, I can tell that the zeros are 2 and 4. That means that halfway between the 2 is my axis of symmetry, which is right here. What value of x is my axis of symmetry at?
3.
3. And I know that the axis of symmetry is x equals 3 if I was asked for the axis of symmetry. They're asking for the vertex. Well, the vertex of my parabola is located at, in this case, the highest point, which is 3, 2. No need to have to do algebra if you could see it as it is. The vertex is 3, 2. Please remember that the vertex is a point, so if you just say 2, it's incorrect. The vertex is 3, 2. Is this a maximum or a minimum? A maximum, because it is the highest point. There will be some that you will be asked if it is a max or a minimum, so it's very important that you do understand that max is the highest. Here we go. Number 7. Identify the vertex and give the minimum and maximum value of the function. Well, in here, the vertex, I hope you can see, is 3, 6. It is a maximum y value of 6, because that's the highest it goes.
We can say y value of 6.
The maximum of 6, that's the highest it goes. The word maximum means also most. And if you're talking about the most, that means that it's reaching the highest value of 6. Okay. Domain and range are those that confuse us just because they have specific meanings. We know, first of all, that domain is referring to the x values and range is referring to the y values. Because a parabola expands infinitely in both directions as it goes down, the domain will always be x such that x is all real numbers. That is the domain, if I wanted to put it in set builder notation like I learned about. If you say the domain is all reals, that is equally correct.
It's always going to be.
for a parabola, the domain is always all real numbers. And again, the reason for that is because my parabola is expanding infinitely forever on the x-axis. All of the x values are going to be part of the domain of that parabola.
So that's always going to be right.
Always all reals for domain. The range is a little different because the range is what are the values of y that are on my graph? Well, I have no values of y up here. My values of y begin here at -4 and go down. So the range written in set builder notations is the values of y such that y will always be, in this case, less than or equal to -4. Because it's all of the values that are less than or equal to -4. Do I expect you to write it in set builder notation?
Yes.
I don't expect you to. However, if you want to be very well prepared for Algebra 2, you will already start putting this into set builder notation. But if I asked you what the range was and you said y is less than or equal to -4, that is just equally correct. If I said, hey, what's the range? And you answered y is less than or equal to -4, that is correct.
Or if you just put
Okay.
all real numbers.
All reals is for domain only.
Yeah, but just for domain.
For domain,
Like
it's
not
all
x
reals.
slash-
For range is y is less than or equal to -4. So if I created a parabola that looked like this, just for the sake of demonstration, and opened upward, again, the domain is that x is all real numbers. But what would the range be? Y such that what?
Two. Greater
Y equals.
Y is greater than or equal to 2. Because it is from 2 up. All right, number 9. These are the ones that are going to probably take you the longest. And the reason it's going to take you the longest is because they ask you to graph, and they ask you to specifically find the axis of symmetry, the vertex, the y-intercept, and 2 other points on the graph, and to state the domain and range. So, I'm going to get x equals opposite of, what's b equal to? Opposite of 4 over 2 times, what's a? -1. And when I do the math, I get -4 over -2, which is equal to? 2. What must I write in order for this to be a x equals 2? Good. So I know the axis of symmetry is x equals 2. So if I wanted to graph that, I would go where?
To the graph.
2 on the x. And then I could make a vertical line. That's my axis of symmetry. Right? What is important about the axis of symmetry in reference to the vertex? The vertex is on it, exactly. So, how do I get the vertex?
You have to plug it in.
Plug what in? The x value into what? So if I know that my vertex is on the x-axis, like you guys said, in order to get the y value, I'm going to plug that in, right? So if I have my equation, which is y equals -x squared plus 4x plus 3. Okay, let's see.
The power is wrong.
So, we know that the x value is +2, correct? So we're going to do -x squared plus 4 times x plus 3. So with this one, it's going to be 4 and then negative plus 8 and then plus 3. What's -4 plus 8? plus 3? 7. So what is the vertex? Oh, we got that. In this case, -4 plus 8 is 4 plus 3 is 7. We got that y is equal to 7. Correct?
Yeah.
that means that my vertex is 2, 7. Because if my x value is 2, then my y value is 7. So when I go to write down the vertex, my vertex, so we have the x equals 2 is the axis of symmetry. The vertex is 2, 7. Then I can graph it on here. 2, 7 is right there. That's my vertex. Now the next thing that they want me to do is the y-intercept. Well, for the y-intercept, the only thing that I need to do is look at what part?
C.
Yeah, the c of the equation, which is 3. So your y-intercept is 3 on the y-axis, which if I wanted to draw it, I would draw it right there. I would just plotted it on my, okay? So if my y-intercept is 3, that means that my point location is 0, 3, because I went over 0, up 3. And then if I plot that on my graph, that means that I cross the y-axis right here. So now I have my y-intercept. So then they want to know 2 other points. Well, 2 other points, the first one could be gotten by reflecting the y-intercept over the axis of symmetry. That's 1 extra point, correct? So if I reflect this, what I'm looking at is I'm looking at the fact that my y-intercept is located at the 3. And if you look at the axis of symmetry, that means that it's 1, 2 to the left. So I'm going to go 1, 2 to the right. Boom, that's another point. So one of the 2 additional points that it asked me for, I could say is actually 4, 3. Right? So 2 other points. Well, 1 point is 4, 3. And now a way to get a third point or a second point, additional point, would be to look at maybe what happens when x is, I don't know, 1. Plug 1 into x to see what y is equal to. If y is equal to negative x squared plus 4x plus 3, to get another point, all you need to do is pick a value of x, plug it in, and find the corresponding value of y. Negative 1 squared plus 4 times 1 plus 3. Well, 1 squared is 1. Negative 1 plus 4 times 1 is 4. Negative 1 plus 4 is 3. And 3 plus 3 is 6. When x is 1, y is 6. That's my second additional point that if I wanted to graph, I would put it at 1, 6, which is right here. And if I wanted to reflect an additional point, I could, and then I would connect my dots. You would reflect so that you could actually get the best looking parabola possible.
I'm so comfortable with this.
So when they ask you for the axis of symmetry, you use x equals negative b over 2a, and you remember that your axis of symmetry is x equals something. When they ask you for the vertex, you're looking for the point at which x is the 2, in this case, of the axis of symmetry you plug in to get the y value. The y-intercept is the point that is located, looked at quickly if you see the letter C. And another point can be found by reflecting the y-intercept if possible, or making a table of values, picking a value of x, plugging it in to do the math. Now let's look at the next part. The next question is asking you to find the zeros. Please remember, that the zeros of a function are also known as the x-intercept, the roots, or the solutions. They all mean the same thing. It's asking me basically, where do I cross the x-axis? And oh, it's so refreshing when you have a graph that you can actually have to do no math and just look at it common sense. Where do I cross the x-axis? -1 and -5. What this is telling me is that the solution to this, if I wanted to factor this or use the quadratic formula, bottom line is that I would get that x is equal to -1 and -5. That's it.
We don't need to put -1.
Remember that when we solved this by factoring, we actually had to say 0 is equal to, and then you did your unfoiling, and you got x plus 5 and x plus 1, and then you set each parentheses equal to 0, x equals -5, and x equals -1. Your answer to the solution was x equals -5 and -1. But we don't need to factor anymore, because if they give us a graph, our solutions are literally where we cross the x-axis, which you guys can see are at -5 and -1, which is the correct answer even if I would have factored it to get the answer. All right, number 11, one more time, just like number 9. It's going to ask me to graph. It wants me to solve by graphing. So in order to solve this, I need to graph, and in order to graph, I need to do all that stuff. So if you notice on the back page, they actually have, this is what it's going to look like on the test. I'm going to have all of those words on the left, and I'm going to have the graph on the right, and your job is to work it all out and fill in the blanks and make the graph. So let's start with the axis of symmetry. I know that the axis of symmetry is the equation x equals -b over 2a. In my current quadratic, I see that a is 1 and b is 2. I also see that c is -3. So when I go to do the axis of symmetry, I know that my axis of symmetry answer has to be x equals something. So if it helps you to write x equals from the very beginning, do so. Well, the opposite of b, which is 2, over 2 times a, which is 1, gives you -2 over 2, which is -1. So when I go to write down my answer here on the right-hand side, I am going to write x equals -1. That is the axis of symmetry. If you want to graph as you go, you're welcome to do that. If you want to graph at the end, you can do that. I'm going to wait till the end this time around. The vertex. The vertex is a point, and that point must be x comma y, where in this case, because I am on the axis of symmetry, my x is -1. So in order to find the y value, I am going to take my given equation and write it as the related function y equals x squared plus 2x minus 3. And then I'm going to plug in the value of -1 for x, remembering order of operations. So those of you that made the mistake with the exponent, remember, always rewrite with parentheses first and then plug it in so that you don't overlook negatives. So I'm going to plug in -1. Then I know that I have to do -1 squared, which is 1. 2 times -1, which is -2. And then when I do 1 minus 2, it's -1, minus 3 is -4. So that means that my y value is -4 when x is -1. I have found my vertex. All right. Next thing. The y-intercept. Well, the y-intercept is very easy to identify, especially if it's an x squared plus bx plus c. It's -3. But an intercept must always be written as a point. So when I go to write my point, I am going to write 0, -3. Because if I cross the y-axis at -3, it means my x value is 0. Are we good? Mm-hmm. Excellent. In order to get the two other points, the easiest thing to do would be to make a table of values and pick some x value that you want to plug in. We don't want to pick 0 because we already have a point with x as 0 right here. We don't want to pick -1 because we already have a point with -1. So we could do 2 and 3, if that makes you happy. Or -2, -3, it doesn't matter. We know that the function is that y is equal to x squared plus 2x minus 3. So if I was to plug in 2, it would be 2 squared plus 2 times 2 minus 3, which would give me 4 plus 4, which is 8, minus 3 is 5. So when x is 2, y is 5. That's 1 point.
Wait, I just mirrored.
Then the next one would be 3 squared plus 2 times 3 minus 3. 3 squared is 9. 2 times 3 is 6. 9 plus 6 is 15. 15 minus 3 is 12. So when x is 3, y is 12. That is the other point. Now, in order to get the domain and the range, I feel that I would like to see my picture, because when I see it, I can actually see the maximum and the minimum and the things. So now I'm going to go in and graph it. Axis of symmetry is x equals -1. So I'm going to go to -1, and I'm going to make a vertical line going down. That's my axis of symmetry. My vertex is -1, -4. So I am going to actually go to -1, -4 and put my vertex. My y-intercept is 0, -3. So I go over 0 up to -3. That's my y-intercept. Now what Ben did was, instead of creating two different points, he realized, because he graphed first, that this is a point that could be reflected over here. And if you did that and named that as another point, that's fine. Then we have 2, 5, which I am going to graph at 2, 5, and 3, 12, which is way up here. Now, in order to make my beautiful parabola, I got to make sure that I reflect these points that are on the right on the left. So this one is just 1 to the right, so I'm going to move 1 to the left. That would be here. The red point is 1, 2, 3, so I'm going to go 1, 2, 3. And then up here, it's really, make sure you're looking how many units to the right of the axis of symmetry. You have 1, 2, 3, 4. And so you're going to go 1, 2, 3, 4, and that's where you're going to get the other point. And now you connect your dots, and you have arrows at the end because the parabola goes on forever. Last questions? Well, what is the domain? The domain is always going to be all reals for parabolas. All reals for domain is always all reals for parabolas. And again, the reason for that is because this is infinitely getting wider and wider and wider. And when you get wider, you're moving on the x-axis. And that means all of the x values. The range is asking me my y values. Well, my minimum is here, and then I go up. That means that my y has to be greater than or equal to, and this one is -4. And that is the range. This is the types of questions that you're going to have.
It says zeros too.
Oh, thank you. The zeros. It also says solve. So I overlooked the fact that it says what are the zeros. So the zeros, if you're looking at the graph itself, you would notice that, well, I believe I'm crossing through here and here, but I might have made my graph a little too wide or my font is not very good. So in order to get the zeros, you have to remember that you are trying to find the value of y when the value of x when y is 0. So you rewrite your formula, you make it so that it's set equal to 0, and you can either solve by factoring or using the quadratic equation or using square roots. You get to choose how you want to solve. If you want to solve by factoring, then you would take this and you would say to yourself, okay, well, I remember that in order to solve this, I had to factor it. And what multiplies to -3 and adds to +2?
-3 and 1.
+3 and -1, because they add to +2. And then I have a simple parentheses. Then you set each of these equal to 0. And when you do that, you would get x plus 3 is equal to 0. So x is -3. X minus 1 is equal to 0. So x is +1. So the zeros would be x is equal to -3 and +1. And then if I was to graph those, you would see that it does go through. I did graph it properly and my font was properly created. And when I say my font, it means like the highlighter that I used in order to connect these. It did go through very nicely through those. So, axis of symmetry, x equals -b/2a. The vertex is -1, as you found here, plugged in to find the y. The y-intercept is the c, which is this part here of the equation. Two other points, you just pick a value of x, plug it in, find the corresponding y, and then if you wanted to, you could reflect it, and that's your other point. So you only have to do it once. I did it twice. Domain is always all reals. The range is, if it's a minimum, it's from the minimum up, and if it opens down, it's from the maximum down. And the roots, you just have to remember, you are going to solve either by factoring or by using the quadratic formula. But once you find your roots, the roots are where I cross the x-axis, and then I could just plot those two additional points. The reason that you cannot just look at it and tell me that the roots are -3 and 1 is because if it was like -3.5,
Yeah, that's what I mean. Like,
right? So
can't really tell.
the only way that you can really get the actual true zeros is by using the method we used in the last section, which is by factoring. And that's the reason why this test is worth 100 points. Is because it is covering the entire chapter, even if you don't realize it. All of the graphing is covering how to solve by factoring, or by square roots, or by quadratic. But you also have a lot of different things you need to do. This is a lot of stuff that you have to do. Number 12, word problem. Again, they want us to find the axis of symmetry, the vertex, the y-intercept, domain, everything, basically. So the axis of symmetry is x equals opposite of b, which is 16, over 2 times a is -1. This gives you -16 over -2, which is +8. So my axis of symmetry is x equals 8. Once I have that, I can get my vertex. My vertex is the value of y when x is 8. So negative x, which is 8, squared plus 16 times 8 minus 64. 8 squared is 64 with a negative in front is negative 64. 16 times 8 is 148. 80 plus 128.
Yeah.
And then minus 64. Well, negative 64 and negative 64 is negative 128 plus 128 is 0. So when x is equal to 8, y is equal to 0. So my vertex is 8, 0. The y-intercept is the c, which is negative 64. So that means that the y-intercept is 0, negative 64. That's a big old number that I have there.
Is that hard?
It won't be that big. Now, 2 other points. Okay, so now I can actually look at this information. And I could say, all right, let me get the stuff all graphed.
There's no 64. Yeah.
That's right, there is no 64.
So you can't graph that one.
You can't graph it,
But can it still be a point?
but it's still, yeah. So you're going to say, all right, my axis of symmetry is x is equal to 8. So I'm going to go to 8, and I'm going to make a vertical line down the middle. My vertex is 8, 0, which is right here. My y-intercept would be 0, negative 64, so it would be 0 all the way down there. I'm not even going to draw it on there. 2 other points. Well, in order to get 2 other points, I need to make sure that I pick some values of x and plug them in. Well, my equation was y equals, because we replace it with y, negative x squared plus 16x minus 64. I'm going to choose 1. If x is 1, then I get negative 1 plus 16, which is 15. 15 minus 64 is negative 49. That's a big number again. So when x is 1, y is negative 49.
Those are way too big for this.
They are pretty big. So let's see what happens when we plunge in negative 1. If you put in negative 1 here, negative 1 squared is going to be 1 and then negative, so that part's correct. This is going to become minus 16. Negative 1 minus 16 is going to be negative 17. Minus 64 is negative 81.
Yep.
So that's the other point. Big points. It's just big points.
What if you just do like...
In order to find the... I would find the roots. And to find the roots, I would take my equation, y equals negative x squared plus 16x minus 64. I would set it equal to 0. And then I would change everybody's sign. So that just becomes 0. So that a is positive. Then you would notice this is a special case. This is actually x minus 8 times x minus 8. So that means that x equals 8 is a root. And if that's the case on my graph, x equals 8, you notice that, look at that. It's the same thing.
How do you graph it?
So in order to graph it, you are going to have to find a way to get those points that we found that were really big. Maybe it means that we need to, instead of counting by ones, we're going to need to count by fives.
Do 6.
So if we count by fives, and again, on the actual test, you're not going to have numbers so big that you're not going to be able to graph them, okay? So for the sake of this part, if we were going to be graphing these great big numbers, then what I would need to do is I would need to count in increments of what do you want? Maybe even increments of 8.
Yeah, do 7.
Or 11.
Do
Or
7
11.
or 11. No, 7.
7, 11.
Do 7.
Count by sevens.
11.
Yeah.
Okay.
Just do 7. 'Cause it
7,
has to be negative
14
1
plus 7, 21.
28.
So 8 comma 0 would be right here. Axis of symmetry is x equals 8 would be this one. The y-intercept is 0 comma negative 64, so negative 7 times 2 is 14, times 3 is 21, times 4 is 28, times 5 is 35, times 6 is 42, times 7, 49, times 8 is 56, times 9 is 63. Oh, 64 is like right here. Then I would reflect that over here, and I would draw my parabola. So I know that this was a terrible one. This was a terrible one, but that's what it would look like. The domain is all reals, and the range is y must be less than or equal to 0, because 0 is the highest point that I get to. Last question. A kicker starts the football game by kicking off. So we know that when we have our picture, we're going to have the football that is kicked. It tells me that the quadratic function that this is referring to is this one right here. It's telling me that the height after x seconds, so that means that y is the height and x is the number of seconds. They want to know how long, so in other words, what is x equal to? How long is the football in the air? What this is asking me is how long from this point all the way to this point. So they want to know what is this x value, right? So if I know the middle point, then I know how much I am distant from here to the middle, and then I can actually add that same amount because it is the same over to the right-hand side. And that tells me what the number of seconds are. So if I say x equals opposite of b, which is 16, or 60, over 2 times a, which is negative 16, that's going to give me negative 60 over negative 32, which if I divide it out, 60 divided by 32, that gives me positive 1.875, which is about 1.9 seconds. That means that my vertex right there, my axis of symmetry, the x value is 1.9 seconds. That means that it took 1.9 seconds to get to here. How many more seconds is it going to get to here? Another 1.9. So altogether, that is a total of 3.8 seconds that I was actually up in the air, because that's the distance from here to here. If the question said, how many seconds did it take to get to the highest point, that would be 1.9 seconds. But they're asking me how many seconds it took for me to get right back down to the bottom. So it took me 1.9 seconds to get up to the highest. It's going to take 1.9 more seconds to get down. That's a total of 3.8 seconds that I was up in the air if I was the ball. An equation that can be written in this form is called a quadratic. The y value of the highest point of the function is the maximum. The y value of the lowest is called the minimum. The shape of the graph is a parabola. And a vertical line that divides it into two symmetrical parts is the axis of symmetry. Boom.